This is the third installment of a series of videos on an attempt at repairing a vintage Black & Decker drill. We fixed the armature in the previous episode. Now we are going to move our attention to the field coil. I am going to use a bow saw to carefully cut the windings. I noticed they have actually used fish paper as insulation and that the wires have been just crimped together. In fact, no connections in this drill takes any kind of solder. I took a zoomed-in photo of the severed winding and counted 166 turns. One thing I noticed is that they have used double-sided adhesive tape to help keep the coils in place. Using my ballpark meter, I measured the wire diameter to show a little bit under 0.45 millimeters. This roughly corresponds to a standard 0.16 square millimeters wire. I have wound 165 turns of the 0.16 square millimeters wire, and out of curiosity I will measure its weight. It is around 42 grams. Let's compare it with the original coil. Oh, well, we have 31 grams. Of course we must discount the copper lost during the sawing, but even doing so, it was not to be that discrepant. Of course I made a mistake. I forgot to consider that the enamel and the varnish coatings add to the measured diameter of the bare copper. So I ordered a 0.16 square millimeters wire, when I should have ordered a 0.13 square millimeters wire, whose diameter is only 0.40 millimeters. The standards refer to the bare copper, not the coated wire. Trap for young players. For the same length of wire, this represents a more than 25% increase in volume. The tight space in which the coils go does not allow for that kind of tolerance. While we await patiently for the new wire, we are going to try to remove this worn-out oilite bushing. We are going to use this long screw. This piece that I found in my junk bin is perfect because it has a flange whose outside diameter is a little bit less than the inside diameter of the bushing pocket and has a shaft that is less than the inside diameter of the bushing. Now I will install it all like that and use this 12 mm socket on the other side. Then I will slide these two washers to adapt the socket to this nut here. Now I will secure this nut in the jaws of a vise and fasten the screw. As I fasten it, it will push the bushing into the socket. So here we have it. My ballpark meter says that the outside diameter of the bushing is 3/8, its length is 7/16, and the inside diameter is 1/4. Now that it is out of the housing, it is possible to see the amount of play this thing has. And we can immediately compare it with a new bushing I just ordered. It fits perfectly with very little play. And now the challenge will be to reinstall it in place. I cannot heat up the housing to enlarge the hole because of these plastic inserts here that I could not figure out how to remove. Since all of this is made of unobtainium these days, I'd rather be cautious. So I will instead leave the bushing in the freezer overnight. And with the help of some oil try to squeeze the bushing in the housing while it is still cold. I also took the opportunity to deburr the rim of this hole and clean it with isopropyl alcohol. Now you can see the bushing in the process of being inserted halfway into the housing. Likewise I will fasten the screw like that and it will push the bushing in. And ta-da! New oilite bushing. I built this jig to wind the field coils. The core of the bobbin is a square of about 36 by 36 millimeters, made out of a 6 millimeters thick piece of wood. Those dimensions I took from the original coils. The jig is mounted like that and the wire goes in through this hole on the side. Now I secure the start of the wire and wind it counterclockwise around the bobbin. Each turn is manually registered by this mechanical counter. Since this is a tedious job, I tune into the amp-hour podcast and do not see the time go by. Now the bobbin is unmounted like that, and the winding is tied with these two strings so that I can remove the core without unwinding the coil. There it is. Now I will wrap it with polyester tape so that I can remove the strings. Now I can remove the strings and wrap these sides with a wider polyester tape. Now you can see both coils tentatively installed. The leads were soldered to the ends and beginnings of the coils and the connections insulated with heat shrink tubing. This is a schematic that shows how the coils should be mounted. I still need to attach the brackets that connect the appropriate leads of the coils to the brush metal holders. The problem is that they used these crimp barrels, and once opened they cannot be used anymore. So I decided to cut off this unused crimp barrel from this terminal and crimp it with a pair of pliers and reinforce the connection with solder. After that I intend to tentatively reassemble the drill for some preliminary tests before we can proceed with the repair. Thanks for watching. Have a good night and stay beautiful.